Welcome everyone to Decarbonizing by 2030, Challenges and Solutions for a Climate Resilient Future by SGInnovate and partnered with Japan Science and Technology Agency. I'm Ziling from SGInnovate, and if you're new to us, we are a government-owned organization in Singapore with the mission to build deep tech innovations from Singapore for the world. We invest in and help build deep tech startups in the fields of AI, medtech, and quantum tech, just to name a few. We work with entrepreneurial scientists and clinicians to help bring their innovative research from lab to market, and we also develop tech talent and engage with a vibrant deep tech ecosystem. Today, we are excited to hear from our panel of thought leaders, Prof. Maury, Prof. Subo, Sinma, Seng-Wai, and Ted, in this panel moderated by our very own Kelly, as they discuss the challenges and the solution for a low-carbon future. Just some house rules. During the webinar, if you have any questions during the event, please post them in the Q&A box at the bottom of your screen. And do feel free to use the chat box function to connect with our wider community. Now, let me hand over the time to Kelly Chan, Senior Manager, Corporate Engagement of SGInnovate, to introduce the panel. Kelly, please.
Thanks, Ling. Hi, everyone. A very warm welcome to this afternoon session. My name is Kelly. I'm from the Venture Investing team at SGInnovate. Before we begin, it is perhaps useful to frame today's discussion on decarbonization. So with climate change accelerating in recent years due to the increasing amount of carbon dioxide in the atmosphere, the world is currently experiencing the consequences of global warming through more extreme weather, rising sea levels, diminishing Arctic sea ice. To address this climate change, all of society, including governments, researchers, companies, and startups, will need to work closely together to leverage on science and technology in paving the path to a greener future. Today, we have an exciting panel of international experts and thought leaders who are able to share more about their insights on the path to achieving carbon neutrality in the next 2 to 3 decades. So without further ado, I'd like to welcome our distinguished panelists, Seng-Wai, Prof. Maury, Prof. Subo, and Ted, to introduce themselves and what they do. So maybe Seng, you can get the ball rolling.
Sure. Thank you so much, Kelly, and thank you for the invitation. Hello, everyone. It's such a pleasure to be here. My name is Xin Ma. I'm the Managing Director of Total Carbon Neutrality Ventures. So we're the corporate venture group of the energy company Total. Total is an international energy company active in oil and gas, clean electricity with 35 gigawatt by 2030 to 2025. And we are also covering a wide range of energy and eco solutions, including energy efficiency, battery, EV charging. I'm really happy to cover those later on. In terms of the carbon and climate policy, similar to a lot of our peers and similar to many countries, Total is committed to reach carbon zero by 2050. So that involves 100% net carbon for Total Group within the scope and 60% for scope 3, which is our clients. I'm happy to share that later on. And for the venture group, we invest globally in startup in the energy, mobility, as well as carbon neutrality field. Our recent investment that you can see in my background is a Singapore-based company called Canopy Power in a hybrid energy, solar plus battery field. I'm very excited to really change with everybody about these exciting opportunities. Pass to you, Kelly.
Thank you. Thanks, Seng, for the introduction. Perhaps you can get Seng-Wai to go next.
Hi, I'm Seng-Wai. I'm a Director for Policy in the Energy Market Authority. And the Energy Market Authority is a statutory board under the Singapore government, where we are the energy regulator for our power sector. So my portfolio basically is helping to steer the power sector towards our future, where we aim to be more decarbonized and still provide reliable and competitive energy supply. So that's a very quick introduction. Kelly, do I have opportunity later to share the slides, or do I have to do it now?
You can share it now if you want.
Okay, sure. So just very briefly, what you see in front of you is the energy story. One slide summary on how we will aim to decarbonize our power sector. So today we have natural gas, which supplies 95% of our electricity supply. So we burn natural gas in the most efficient manner, and we aim to improve its efficiency over time as technology improves. Right. We're also growing local solar production. So we aim to deploy, today we are at about 350 megawatt peak to 400 megawatt peak of installed solar. And we aim to increase that by at least 5 times by 2030, right? And this can provide perhaps say 3 to 4% of our total electricity needs in 2030. So it's not a very big amount, to be honest, because Singapore is a very small and energy dense location, and solar requires quite a bit of space to deploy, even when you use up available rooftop space. So to help to decarbonize further, we're looking at the regional power grids, where we hope to access renewable energy from overseas, as well as low carbon alternatives such as hydrogen and carbon capture going forward. And of course, we hope to improve energy efficiency. I will not go through this slide that talks about technology opportunities that arise from the energy transition that we hope to see in our power sector. But what I can say is that it's quite varied. There are opportunities across various areas such as energy production, like solar, hydrogen, batteries, that kind of thing, as well as energy consumption, like energy efficiency, demand response, electric vehicles. So this slide I'm happy to share with the audience after the event is over. Thank you.
Thanks for the introduction. Perhaps you can get Prof. Mori to go next.
Yeah. Okay. May I introduce myself? My name is Shinsuke Mori from Low Carbon Strategies Center for Low Carbon Society of Japan. I have engaged in global warming issues and energy modeling issues and so on. I participated in the IPCC activities in the third assessment report. It's already 20 years before. I developed some integrated assessment models involving energy, economy, and food and land use, and so on. But recently, I'm studying about mainly the national energy model or regional energy models, because the Japan faces aged society and population decreasing society. Therefore, our energy and economics issues should be re-evaluated from the beginning of regional activities and then come to the national issue and then contribute to the global issues. I would like to show some 2 slides on the introduction of my center. I will show you 2 slides, not so many. Yes, this is the structure of our center. The figure is very much complicated. Therefore, please visit the website of our center afterwards. What is important is we are studying about the research development issues, but not only the technology itself, rather the evaluation of engineering and economies. Oh, sorry. For instance, proposal for the industries and proposal of innovation by their carbon technologies and systems. That consists our research subjects constitute technology evaluations, social and economic issues, and energy economics issues, and so on. Afterwards, I will show you some slides on the Japan governmental proposals and the directions. I myself are now interested in the regional energy systems, including biomass, but probably energy issues is not the only one. The energy issue should be connected with mobility, lifestyle, economy, and so on. Afterwards, I'm very much interested in the discussion. I hope we can share some findings and new directions of our activities. Thank you.
Thanks, Prof. Mori, for the introduction. Perhaps we can get Prof. Subo to go next.
Sure, my pleasure. So I'm also going to use a couple of slides to illustrate some of the topics that we're working on. So I represent the Energy Research Institute at NTU in Singapore. I'm a professor in material science and engineering, and it's really a pleasure to be here to discuss the topic at hand, decarbonization. I think as the cartoon shows here, I think we have been hit by one challenge after another. Beyond the COVID and recession, really the bigger challenges that we go forward with are climate change. And even a bigger wave beyond the climate change is the challenge of loss of biodiversity. And really the major concern is unless we halve our emissions over the next decade and we go carbon neutral by 2050, I think this challenge will be very difficult for us to tackle. In reality, there's every indication that we will overshoot the target. So it's even more urgent to discuss not just carbon neutral solutions, but net carbon negative solutions as well. And really, sometimes we wonder the rate at which we responded at COVID, can we respond to that, to climate change in the same manner? And I think the only chance there is for us to understand the devastation that climate change related topics are causing from a financial perspective, and that no one country is going to be immune or are going to be spared by the challenges of climate change. And I think the economic impact of this is so great that there's a clear momentum in discovering new means of decarbonization. And that's basically what brings me to the next slide. So this is a very interesting chart that shows the emissions as well as the carbon management opportunities which are available to us. And this is available on the website at this address at the bottom here. I won't go through all the possibilities in this chart, but the possibilities in terms of how will we address carbon abatement varies from CO2, fixing CO2 and making it into fuels, to enhance oil recovery, to bioremediation, forestry, biochar, and so on. And perhaps in some of the discussion sessions, we can tackle some of these topics. This is basically what's going on in Singapore and some of the projects that we are engaged in. Again, I'm not going to go through the details of this, but the projects range from solutions which would be steeped in hydrogen economy, solutions that would definitely target carbon capture. And finally, there are different ways in terms of multi-energy systems and digitalization can be used to tackle climate change as well as decarbonization. I think I'll stop with that, Kelly, and we can take questions later.
Okay, thanks for the introduction. So last but not least, we have Ted.
Hi, my name is Ted. I'm the co-founder of Evercom, and on the side, I'm also a technical consultant for the United Nations. So for Evercom, we are an energy AI company that focuses on helping government and large enterprises and also small enterprises to move towards the movement of low carbon operations. And I will share a few slides for illustration purposes. So the belief that we have is in terms of technology, we do have what it takes to really help us move towards low carbon operations. But the challenge is that how these technology are being distributed to the industry right now is through a very not so effective manners. Most of the time it really relies on consultant to push through. And if you look at the number of buildings, industrials, commercials in Singapore, we simply just don't have enough expert consultants to facilitate this at a much faster pace. And for us, this is why we leverage on AI to help make this kind of assessments and recommendations. And ultimately, what we're trying to do is to work with research organizations like Ariane, as well as other big organizations, to see how can we quickly facilitate the right low carbon technology into the right customers. You know, these can be in the commercial space, industrial spaces, and so on. So yeah, this is what we do, and happy to discuss more and share more in this panel.
So thanks everyone for the introduction. So perhaps to start us off, the first question I'd like to ask is, what roles do governments, researchers, corporates, and startups play in the whole decarbonization roadmap? So maybe you can get Sing Wai to go first to share from the government perspective.
Thanks. Okay, I think the government's role in this case really is to set out the overall policy direction and the ambitions that we have, so that we send the right policy and market signals to industry and to consumers on what we think will work. Of course, we don't claim to have the answers, to be honest, for many of these issues. So when we set out a policy direction, that means things like we aim to decarbonize the whole of Singapore, for example, over time. And some of our public commitments are that we will peak our carbon emissions in 2030, and thereafter we will halve this by 2050 and aim towards net zero by beyond 2050, right? And of course, if you look at many other countries that have very similar ambitions, then what we do is we will set up the policy and market measures that enable this. One example, we have a carbon tax, right? So we have a carbon tax today. It's a modest one, but we have said that we will be reviewing this and with a plan to increase the carbon tax numbers over time. And we are also encouraging the adoption of green energy as well as energy efficiency. So for example, we have really pushed ahead with solar adoption through government programs. And we also have been announced that we will be changing or basically ensuring that the vehicle fleet by 2040 will be electrified, right? So these are some of the policy measures that are in place, but just because they are policy doesn't mean they will turn out to be implemented. It really requires keen partnership with industry, with researchers, with consumers to really make this change happen.
Thank you. And perhaps we can also hear from the researchers, and perhaps Prof. Maury, we'd like to go first before Prof. Subodh.
Okay, thank you. This is a very interesting and but difficult to question, because in the early days of global warming issues, mainly the discussion is driven by researchers, especially natural scientists and engineers. In those days, the researchers provided cautions and discussed this issue from the long-term views. But after the implementation issues, economics, and so many policy issues and industry people participated in the discussion. Then the issue moved from science to implementation and sometimes policy and political issues. Then probably the researchers give a long-term risks and cautions, and then government raised policies, and industry people tried to how to implement new technologies and so on. This is okay, and but this flow worked in the conventional industry and economic structures. Currently, as there are many people pointed out, information technologies showed a very rapid progress, and the structure of society and economy is now rapidly changing. And in my view, the startups and innovations can propose new ideas never existed in the past. Then the economic structure is almost every time is changing. Or for instance, the energy economists developed models based on perfect foreseeable information and perfect competition. But currently, the situation is not at all foreseeable. Therefore, and once new technology and innovation occurs, the nonlinear expansion of new technologies covers all societies and moves to the next society. Therefore, the constant re-evaluation of technology and policies are needed. This is a very interesting situation. As a part of model builders, we want to see or foresee or to draw a big picture on the future. cautioning and providing new information and policy directions. But currently, we have to reevaluate ourselves much more. But what is important is the synergy effects among fields. I participated in some governmental committees talking about new technological options and opportunities and policy measures. But the situation is changing very rapidly. For instance, information technology has progressed very fast. And one example is the cost of photovoltaics. As I told you before, I participated in the IPCC more than 20 years before. Then the major options were nuclear power and the potential of fossil fuels. No one thought photovoltaics could play a main role. In these 10 years, wind power and many renewable technologies are diffusing and implemented by almost the world and changes the situation of researchers itself. What is interesting is 30 years before we talked about the future global model. Then one major player was Soviet Union. But after 10 years, Soviet Union disappeared, but a new global economic structure appears. Nonetheless, I would say the researchers should provide long-term risks and uncertainties, and starters and innovation initiatives should provide new ideas, even if very few part of their ideas could be successful. Still, they initiate the change or new transitions. And industry people and governmental people should provide policies. Under these situations, the development of strategy, the long-term policy is okay, we have. And the technological options are in hand. We have hydrogen and so hydrogen and internet technologies and so on. But how we can develop strategies connecting these options with each other. This is the largest subject of the researchers currently. This is my view. Afterwards, I'll show you some activities or government activities and industry activities. But what is important is the interactions and the synergies among fields. This is just a problem for us. Thank you.
Thank you. Possible.
Okay, all right. So I think the question is pertaining to the role that a research institute can play in terms of decarbonization. I think being from a research institute, the first thing that we focus on is how can we use technology as a solution. And what we need to focus on is what is the next generation technology that can create a breakthrough. If the technology is near market, we would leave it to the companies to take it forward. But we really need to ask the question, what is the next breakthrough that can accelerate the challenges in decarbonization? Once that is done, once you have the proof of concept, then really the role we play is to work with the companies, either startups or large corporations, and address questions as in scaling, and address questions as in how do you bring down the cost? And that's something that Prof. Mori has addressed extremely well. I think what we have seen with solar technology is breakthroughs have happened in terms of efficiencies. New technologies are coming to the fore. We have economies of scale in manufacturing and process development. And with the deployment, the costs have come down to make solar electricity the cheapest form of electricity generation. So I think that is the role that we can play in partnership with governments as well as in close partnership with companies.
Thank you. First, from the corporate perspective, we can get Singh to share a bit more.
For Kelly, so it's such a wonderful points highlighted by the previous speakers about different role. So for us, we are very, very clear. We think this energy transition and climate challenge are such a big challenge faced by human society. We cannot reach this without the government, without the business, and without customers and the research and innovation communities. And as Saiwei has rightly pointed out, the government really need to set the right signals, carbon tax, carbon price. And most importantly, this is not a single country issue. The government really should have set up the right international collaboration scheme so that all the countries will work together. And for the consumers, I think it's very important that the consumer are using their purchasing power to make rational decisions to choose for the responsible sourcing product. And then for the business, I think it's extremely important for the business to make the right decision, to make the right investment, and find the right business model and technology to deliver and execute, because all these are very huge projects needed. And all this we cannot reach without intelligence and human invention provided by the research community and the startup. So probably just giving examples of Total, the most important thing is, I think, first to set the roadmap, a clear roadmap. Where do we want to achieve? I think a lot of other companies and countries do the same. And then define each stage where we want to go there, and then looking for the right pathway and gateway for us to start from today and reaching where we want to go. And to more concretely, I think the strategic focus of Total is, first one is clean natural gas. I think as our professors mentioned early on, we still need clean natural gas in the energy mix. And the second one is a clean electricity or green electricity. We need to have more and more renewable energy to be on board in the electricity mix. But at the same time, we need digital solutions, because all this renewable energy is going to bring some uncertainty and challenge to the grid. So we need digital solutions to really increase the robustness of the grid, and to working on solutions such as vehicle to grid, smart meters, smart charging, and all the smart, intelligent grid management system. We need battery, we need storage. And all this is not enough. We still need to carbon capture and storage, which is already reality now, and in the future, direct carbon capture, and play an important role for hydrogen, for bio energy, and bio kind of fuels. And I think it's an ongoing thing, and we really need to work together to find which is most cost efficient one, which is the most carbon effective one.
Thank you. Perhaps we can get Ted to share from a startup's perspective.
From the startup perspective, I think every stakeholder has a role to play here in order for all of us to achieve the thing. But where startups can really play a role is out of all the stakeholder. I think startup is the most nimble one in comparison to the other group, from government to corporations to even large research institutions. And as I mentioned, when we work with our hundreds of different customers from different sectors, the biggest problems that we face, and also with governments around the world, is that everyone will go to these customers and tell them that their technology is the best, right? And then it's very difficult for them to make an assessment. So the job of a startup, what we have been doing is simply just seeing how we can better aggregate informations and present information across different technology using benchmark and guidelines coming out from governments and also university institutions, so that we can give the end user a more informed decision on what's the cheapest and quickest way to decarbonize. In my opinion, I think to reach to net zero, we still have a lot of R&D to do, but just to reduce the carbon emission from the current baseline, we already have plenty of technology that can help that. And a lot of these companies are not adopting it just because it's very difficult to choose, right? So that's something that I think the startup can play a role to be a slightly more nimble forces to bridge the different gaps between the different stakeholders.
Thank you everyone for sharing. So perhaps just moving on to the next question, like what are examples of alternative energy that can help us transition into a low carbon economy? Anyone would like to take the question first? Maybe Prof. Maury, would you like to go first?
Okay. I would like you to talk about some examples about that. Probably the hydrogen is mainly expected as a future energy carrier. Especially in case of Japan, the energy or for fossil or liquid energy should be transported from abroad. Hydrogen could be one possibility for us. And just like the water electrolysis, we can produce hydrogen by ourselves. But for that, we need very large amount of electricity. If the nuclear power is still available, then probably we can produce hydrogen much more. But today we have to look for another pathways to produce electricity. And yet, probably we can have so many power generation options as well as photovoltaics and other renewable energy options. But probably the most important issue is not the energy source, but the energy services. Just a case of ESR's LED low energy demand scenarios, they talked about the possibility of very few energy consumption with same or much more energy services. It's one direction for us. We have to reduce carbon emissions, energy consumption, and energy demand at the same moment. In this sense, there are information technologies, as many of you talked about, is the center of this issue. We can manage total energy systems much more than today, or much more than conventional world. But we should remember the information technology itself requires very large amount of electric energy. In our institute, trying to evaluate the future consumption of electricity by ICT or by ICTs. As you know, the capacity of data center is expanding very rapidly. If this situation continues, probably electricity for data centers and other information and communication technologies should might grow 27% per year. it's too much. But probably it's possible until 2030. After that, we should develop new energy technologies and new information technologies as well. And what is important is we need the energy management and whole integrated management system at the same moment. For instance, we have so many possibilities on electric vehicles. But if all electric vehicles require to charge your power in the morning, then probably all power generation stations would be crashed. We need new management systems as well, covering all regions. And this is my comment. Hydrogen, electricity, and probably other energy carriers would substitute the energy consumption and fossil fuel consumption and probably carbon emissions at the same moment by reducing energy demand and keeping energy service as the current situations. And I would point out one geographical conditions or climate and weather conditions of Japan. It is our winter seasons. Therefore, we have much snow in the north area. Then, photovoltaic power stations can't work because of the snow falling. And to too strong wind, such as typhoons, we have to stop the wind power stations. A very similar situation occurred now in United States, probably Texas state and other states. We have to think about the implementation of such variable renewable technologies and backup technologies as well. Their frustration is much more being complicated than complicated, but still, I think the information technologies and the new management system will give a good solution for the next future. I'm sorry, I can't answer well.
No, it's okay. It's very good.
Yeah, I can see so many issues, but very few solutions at the moment. Sorry.
Prof. Subodh, would you like to go next to share
Sure,
some
certainly.
examples? Yeah.
So the question, Kelly, is regarding alternative energy, correct?
Yes, examples of
So say that again.
examples about
Okay,
alternative
all
energy.
right.
Yeah.
So I think without a doubt, as I said earlier, the solar electricity has now proven globally to be the cheapest form of electricity generation, even cheaper than coal. I think a close second in today's world is definitely wind power. I agree with Prof. Mori's assessment that both of these have challenges, but these are the most promising. And if you look at 2050, these would constitute 60% of our electricity generation at that period. But we really still need to be open for other alternatives. And I think in a large part of the world, hydropower is a genuine alternative. Geothermal has been explored. Hydrogen economy is coming, no matter, I mean, it may take 10 or 20 years, but hydrogen is clearly the future. But I do want to give in a couple of shout outs to technologies we don't know about yet. For example, plasma fusion or nuclear fusion. I think fusion energy has been spoken about in the past, and it may take 20 or 30 years, but I think we need to be ready for the long game here. The challenges that we have in energy are not going to be solved in the next 1 or 2 decades. We really need to look at what solutions would become available or would become cost effective over the next 50 to 70 years. And I think there is significant hope in terms of fusion to come through by then. Small modular reactors is another technology that is being developed. And I think it's proliferation of multiple technologies and these technologies, alternative energy technologies working together would need to provide the total solution. We cannot bet on any one particular alternative energy solution.
Thanks for sharing. Singwai, would you like to go next?
Oh, I totally agree. So solar renewables, especially if it's from overseas, it's going to be a game changer for us if we can bring it over here. And of course, you can't really import everything without affecting your energy security. So you need to, you can't import everything through electricity without affecting your energy security significantly. So you probably need something else for diversity as well. And overseas produce hydrogen that's green and brought to Singapore through a cost-effective carrier is probably the next best bet. Nuclear is always an option as long as it can be done in a Singapore context.
Thank you. Sing, do you have anything to add?
Yeah, it's excellent points that has been laid out by the previous speakers. So probably if I may, Kelly, I will step back a little bit because when we talk about climate challenge for the energy company, we see two things. We see climate challenge and we also see energy transition. The reason for that is energy accounts for 80% of the CO2 emission. And the world is really undergoing an unprecedented, very massive energy transition from the system that we used to before to a system that we're going to discover. So what we see is, I totally agree with our previous speakers, there are already a lot of commercially proven low-cost solutions that already been laid out in so many countries, including the renewable energy. Our view is really, we really have to see this as a system. We really have to address this country by country, region by region. The basic thinking is we think overall the world is going to become more electrified. So basically, for example, instead of having ICE vehicles, we're going to have more and more electric vehicles to be on board. The same for home, the same for other energy consumptions. And then at the same time, we need to bring better energy for the world, because the human population is going to grow 8 billion by 2040 and 10 billion by 2050. So we need to have better energy. When we see better energy, I think the most important things, they have to be green, they have to be clean and with low or negative carbon content, and they have to be affordable, so that people will not going to pay a big fortune. You have to have good decision to make sure those are the most economic viable source. And the last one is they have to be accessible. So for this, we need to have more and more renewables. That's no doubt solar, wind, geothermal, why not? And biofuels, and to incorporate them in the system, in the grid. We need battery, we need energy storage, different sort of energy storage for short term, for long term, and we need digital solutions. And hydrogen is definitely going to play a very important role, especially for sectors that is difficult to be penetrated by electric mobility, for example, for heavy duty trucks, for aviation. And hydrogen is definitely going to play a critical role. And nuclear, exactly, very important sector to keep keeping an eye on them. I think the professor has mentioned about small modular. We totally agree that those are things we cannot just ignoring them. And digital solutions, and most importantly, although it's not an alternative energy source, but natural-based solutions to capture CO2 or CCUS and direct capture. And all this has to be a package to apply the case by case.
Thank you. Ted?
Yeah, I think I have to agree with all the stakeholders, and it's quite exciting and interesting when, for example, when I'm on mission trip with the United Nations, go to these countries, emerging countries, one of the most interesting discussion is always about, how can they plan forward for their energy resources, because there's so many options, and then there's so many different opinions as well. So from that aspect, I think we definitely need everything. There's no one single source that can be there. But from a startup perspective, again, it's down to the definition of a long term. In a startup, long term means no more than 3 years. For us, 3 years is long term for us already. So if you're looking at 3 years as a horizon, when we work with 500,000 factories in these regions, the only possible sources for them is maybe renewable. But even on the renewable side, where we see really can help them decarbonize is really just to improve their efficiencies, right? And reducing on their wastage. These two combined in our definition of long term will have much more immediate impact compared to a lot of these emerging technologies. So it really depends on what's your perspective of long term.
Thank you. Maybe just also building on that question, all of you mentioned like solar, wind, how hydrogen, nuclear are examples of alternative energy. So what kind of challenges do you see will be associated with this transition? Maybe Ted, you can go first. Yeah.
I think for, again, my definition of long term, the hardest ones that most of our customer faces is that to integrate renewables into their current infrastructure, the cost is just too expensive in general. Yes, renewable like solar has now been more available, but in general, solar in these regions only cover maybe a small percentage of their total energy consumption. We're talking about factories and even household and etc. Right? So how can we interface the renewables cost effectively into these 500,000 factories or even millions of households? I think that's really remain the challenges to be resolved, and that's why for us we focus more on the aspect of cutting down waste rather than introducing renewable for these sectors of the customers. But cost is definitely still an issue to integrate renewables into their operations.
Thank you. Singh?
Yeah, sure. I really, as said, it's a big challenge, and there are quite a lot of obstacles we can see. I think the most important challenge that we see is a lack of a clear CO2 pricing. Probably just give example on that, the importance of that. For example, we are exploring, are we investing in different kind of technology and business model. For example, one of our recent investment is in alternate protein. So they're using biomethane to producing a fish feed. And for this, they're going to use a lot of CO2 and hydrogen. And how are you going to have your business model and have your millions and billions capex to be planned in the future when you don't have a clear pricing signal for the future CO2 price? I see that as a foremost challenge. So I'm really happy to see the book from Bill Gates. I really recommend us to read it. And I think that's also what he also pointed out, really the foremost important thing. And I think the second thing is really a very rational thinking and not to do radical decisions, because people can have good intention with not information supporting their intention to do radical decisions. I think that's really what we try to avoid, because what we are talking about is massive transition with millions and billions of infrastructure and capex expenditure. We really need to have a really a rational thinking for all the stakeholders to decide what would be the right pathway. There is not an answer fitting for all countries and all regions, what we can see from Texas energy crisis that is going on now. And the third one, I see the challenge is the investment bubble, because we have been around for a long time. The venture team has been investing since 2008. Very often we are very lonely compared to the other like TMT or some consumer digital solution providers, because energy and B2B solutions, they take a long time. They are very capex heavy, and Ted knows very well how difficult it is. But suddenly, I mean, in the last years, and probably the COVID helped that, we have a lot of money and pull into the sector from the government, from like traditional private equity funds like BlackRock. And it is a great thing, we welcome that. But what we want is, again, to do the rational decision, not just to pull all those money in, because it can be bubble and it can come into not the right technology. And when the bubble bursts, we don't have enough money to invest in the much needed energy transition. So I really see those challenges.
Thanks. Sing-Wai?
Okay, so I think we spoke a lot about carbon tax, etc. And I do think that there's room for carbon tax to increase. Of course, there are natural, there's a natural need to balance also with cost to consumers, etc. And I'm looking for the numbers of how much exactly the carbon tax translates to cost to consumers in the electricity prices. I'll come back on that. I'll probably type it out. But in the meantime, let me talk about two other challenges I think that will arise. The first is that when it comes to local renewables, there's this issue of intermittency. What this essentially means is that for any given solar panel on a roof in Singapore, for example, the worst case scenario when it comes to solar output can be as much as an 80% swing in output from 1 minute to another. And that's because of the amount of cloud cover that Singapore is under, right? You can have very little clouds to a lot of clouds, depending on how fast the cloud moves above you. And that can contribute to a very big change in solar output. And as solar deployment increases in Singapore, the grid will have to manage that. And I think the technology solutions arising from that to address this, as we have seen in other countries, will be the deployment of batteries, as well as possible demand-side measures that will help to smoothen the flow of solar output into the grid. Just one. And speaking about big, hairy challenges, like Singh has kindly pointed out, if you're going to look at hydrogen as a key lever for energy transition, that's a lot of infrastructure. Today, the Singapore system essentially is run on 95% natural gas, which means there are a lot of natural gas pipelines in Singapore, all buried underground today. If you were to transition to hydrogen, you actually can't use most of these pipelines because hydrogen is inherently a different kind of gas. You can use some of it, but you can't use all of the same pipelines because hydrogen, obviously being a smaller molecule, can leak through the pipes more easily. It has to be transmitted at a much higher pressure and gas pipelines are not designed for that. And so there's a lot of like, literally, you can imagine you are rehauling your entire suite of transportation infrastructure, import infrastructure, consuming infrastructure as we do the hydrogen transition. It will not be easy, but I think when the price signals are there and the policies are there, that could happen in the future.
Thank you. Prof. Subodh?
Well, I think a simple challenge, I'll say, I think we are moving too slowly. I think the urgency is the biggest challenge in terms of implementation. At the rate we are going, it's going to be too late. So I think we need to figure out how to scale quickly and how to implement. Again, I go back and use COVID as an example. We could create a vaccine in 350 days. We need to provide solutions for climate change quickly. And that's the biggest challenge.
I will talk about some point, some different point. Just point about the behavioral changes of people, especially students. Some people like to purchase new technological options, even if they are expensive. Just the case of photovoltaics for home and the hybrid automobiles were initially implemented by some people in Japan, as well as some so-called Hollywood movie stars in the United States, because the new products felt cool or smart. And the opposite side, opposite effect is also beginning. The photovoltaics and the thermal insulation for houses are economically justified and probably cheaper than conventional buildings in the long view. But very few people want to implement such thermal efficient buildings. They don't, especially the house owners, don't like to invest such thermal insulation options. Therefore, some people implement new technologies in spite of high cost, and some people don't like to implement efficient and economic materials, even if they are cheaper than conventional. Therefore, we have to change, or we have to overcome such barriers of people. This is for the first one. Probably the new measurement and the new institutions to initiate the implementation of new. But that's not all. We have to think about how we can choose and overcome such psychological barriers, which are often not rational. Some are irrational decisions, but still we have to overcome these. Therefore, technology should go with new institutions and new value judgmental feelings. If they felt cool or smart, they would implement in spite of the high initial cost. One interesting example is the selection of automobiles. In the world, especially in the urban areas, many people wanted to buy super utility vehicles, very large, strong, and high power. But in the urban area, such SUVs never work well. In other words, they don't need such a large SUVs in the urban areas, but still, it's sold. And how about the small-sized cars and mini-sized cars? Yes, they have some markets, but very few people like to purchase such small-sized vehicles with large SUVs. the challenge and the potential will be the new sharing systems and and some other new attitudes in the world. This is the case for consumption consumers, but in the industry sectors, we can find so many barriers very not can be easily solved by technological options. In the case of iron and steel industries, yes, we have some options, so called hydrogen, steel, and in the cement industry, we can find new technologies. But in such material industries, because Japan is still driven by such manufacturing industries supported by conventional iron, steel, and chemical material industries, we have to find new options. But currently, it's a very challenging story to provide new materials with low or zero carbon emissions. I would summarize my comment for consumers. Such a value judgment is the first challenge and barrier, and for industries, we have to develop so many opportunities. Heating, process heating is also the issue. Yes, we have so many issues. Thank you.
So I noticed that we're coming to the end of the session. So perhaps one last question before we end this panel. So I think earlier everyone brought up very good points, like how COVID has shown the possibility of moving fast. But I think also partly because a lot of governments are making a mandate to sort of make a vaccine for it. But definitely changing mindsets take a very long time. So I mean, in your opinion, what do you think can be done to actually change the mindset of people to accelerate the adoption of low carbon technology? Yeah, maybe Sing-Wai would like to go first.
Be mercenary about it. Price. Price is the best signal. That's what we have realized. Because there is the EMA has actually launched the open density market, right? A couple of years ago. So this allows you as home consumers to buy electricity directly from retailers, and the discounts can be as high as 30%. And our data has shown that when you get discounts in consumption, people consume more. And obviously, if you flip the logic the other way around, if prices are higher, then people consume less, right? So price signals are the strongest signals that I think we can have, and the carbon tax can help to influence that. But at the same time, it's not just about making people pay more. I don't think that's the intention. The intent really it should be about also how can the decarbonization technologies be made cheaper, right? How can we encourage energy efficiency and intelligent use of energy so that people save money overall? So I think that will be really how we will take this forward. Of course, consumer education and everything is a useful and important foundation, but price is what sets the enduring signal to change.
Thank you. Sing, would you like to go next?
Yeah, sure. I think the first one is just we just need to communicate, all of us, the government, the scientists, the startup and companies, to communicate, because we see that there is, from the COVID and from the general, the public are very, they realize the urgency to do something, they want to do something. But we need to communicate with them to make sure this do something will be something rational, because energy system used to be like a big planning system with big agency. I used to work in China, and they have all this very pre-fixed planning. And the companies are very large companies with large projects. We probably are not the best to communicate with outside world. But with this challenge, we need to take in new technology. I think we have to be open, be communicating, educating. So for people to really participating in this and do something and jointly make the rational decision. I think that's the first one. And secondly, I totally agree with Sangwei. You cannot just put people there and assuming that they are going to make moral decisions with their income, because there are very well-off people that can do these decisions, but there are people who have no access to energy and resource, very low income. They cannot do this. So at the end, price has to come down. This has to come from everybody, from the scientists, from R&D, from startup. You know, we've seen the battery price drop so fast. We've seen the PV, solar, and wind turbine become cheaper and cheaper. And there are more like hydrogen now is still very expensive, especially green one. I think they are going to come down. Same for solid state battery, very expensive now. I'm sure they are going to come down. So at the end, we have to propose better, cheaper solutions for people rather than assuming they are going to take the cost.
Thank you. Prof. Subodh?
I know we are running out of time, so I'll keep it very short. I think I come back to some of the user behavior and so on that was mentioned, but I think an important aspect is consumers demanding change. Consumers demanding change from the government, from the companies that they are buying products from. And I think that is what will be a catalyst for change.
Thanks. Prof. Maury?
Meeting. I think the center of the issue is not the energy or environment issues, but the SDG or sustainability of the society. In this view, energy is needed as a basic infrastructure of our society and future. In this sense, I agree with Professor Sabdo. New technologies, everything new is needed, and the consumer is demanding new options and technologies for themselves, not for others. But finally, the collaboration and communications would help and diffuse, and which will cover all the world. Just think about the long-term past. Thanks to the communications, we can share our knowledges and technologies. And today, mobile phones, photovoltaics are diffused and covering all over the world, and they provide new information, new knowledges. I think the energy issue and the new options are just a case. The communications and the new possibilities will provide a new transition and a new society, and which will change over the world. Even if it sounds too optimistic, but still, I would say this should be realized in the near future by communication and exchanging knowledges.
Thank you. So last but not least, Ted.
Yeah, I agree with the panelists. I think we have the consumers are demanding change. So I think what needs to be there is really just a better business model, and the transparency would really help in terms of coming up with better business model that can lower the cost ultimately for the end user.
Okay. Thank you. Thank you, everyone. It's a pity that we couldn't cover much in this 1 hour, but I hope everyone had a very insightful, got a lot of insights from this panel. So I'd like to thank our panelists, Prof. Maury, Prof. Subodh, Sing-Wai, and Ted for your time and generous sharing of your viewpoint and perspective. I would like to thank the audience for joining us this afternoon. So maybe Zing, I'll pass it back on to you.
Yeah, thank you, speakers, and Kelly for their moderation and the great panel discussion. And as you have mentioned, thank you to our audience for your time and great questions. It's a pity that we couldn't go through all the questions, but we do hope the discussion can continue and grow offline, and we can be the change we want to make happen. So do keep an eye out for a post-event email with the recording to the session and the speaker slides, as well as potential ways to connect our speakers through LinkedIn. Until we meet again, bye-bye, and stay safe. Bye-bye.